discussing about internetworking operations. In that, we have seen that how multicasting generates smaller loads, right? As compared to multiple unicast and broadcasting. Uh, and then, since when we talk about multicasting, uh, right, to generate a shortest path tree between a source and a destination, like in multicasting, different members of the group may be scattered on different networks. So, and the membership of a particular group uh, may be permanent, but mostly it is uh, dynamic in nature. So the group members join a particular network, a particular group, and then they leave the group as per their convenience. So it is more dynamic in nature. So just to keep a track that how many members of a particular group are available on a particular network, right? We need some mechanism. We need a mechanism to keep a track record of that, right? So how can we keep a track record of that? So basically there is a protocol that I was talking about in the previous class that is called as an IGMP, Internet Group Management Protocol. So this group management protocol exchanges, it allows the host and routers to exchange the information about the multicast group in the form of messages, right? And it exploits the broadcast nature of the LAN, right, to share the information among multiple hosts and routers available on the network, right? So suppose like as I told you that IGMP is available in different versions. Am I audible to you now? Suraj Kumar Jha, am I audible?
Yes, you are audible.
Okay. So basically when the host sends messages to routers to, basically first of all, a member has to subscribe a group, right? So generally you join a particular group, a WhatsApp group or a Gmail group via some invitation, right? So similarly, in the similar manner, a host which is a host who is interested to join a particular group sends messages to the routers to subscribe a group, right? To subscribe and unsubscribe from the multicast group, so that the routers can have the record that how many group members are there related to this particular group. And basically a group is defined by a multicast address, right? So if I say about the initial version of IGMP, okay, host could join a group, but they were not allowed to unsubscribe the group. Okay, generally the routers use timers for unsubscribing the members. So once that time expires, the router unsubscribe the host from the group in IGMP version 1. So and receivers, only the receivers have to subscribe a group. Okay, the sources were not supposed to subscribe the group, but they can send the data in the group. So it was very inconvenient, because first of all, like it breaches the security, because anybody can send you a message though you are interested or not, right? But they can send a message. जैसे हम लोगों का था, अगर आपको याद हो, still we receive a lot of spam mails and spam messages. तो जो आया ना आपका एक Supreme Court gave a ruling that you have to register on this no commercial ad, then you won't receive messages on that. So in a similar way, the senders can send the messages to the receivers. Okay, and senders were unknown. Okay, so in that it was very inconvenient. First of all, there was no option. If I do not want to receive, then also I have to receive it. So spamming of multicast groups was an issue, right? So even though there are application level filters, but they are also not that very effective. And establishment of distribution tree is problematic because you do not know where is the source root, because you are unaware of the source. So you cannot draw you cannot find out a shortest path tree, right, or a spanning tree. So these were all the difficulties in IGMP version 1 and version 2. So in version 3, basically, a filtering capability was added so that a host, if it doesn't want to receive messages from a particular source, it can filter out that. Okay, it can say I do not want to receive from this source, right? So that traffic will be blocked. So this was a modification in IGMP version 3, and the host can subscribe and unsubscribe a group, right? So IGMP messages, basically there are 3 types of messages in IGMP. Membership, there is a general query. One is a this is a message query, okay, membership query message, okay, and there is a membership report message. Okay, I will come to these parts. First, I will say what is the membership query. This membership query is generally sent by a multicasting router. So this query can be of 3 types: general query, a group specific query, group and source specific query, right? So general query, actually, what is IGMP? You just visualize it that what is IGMP. Suppose on a one particular network, there are some hosts connected on a one particular network. Those hosts may not necessarily be from the same group. Okay, they may be a part of different groups, right? Suppose if I take an example in a way like in a hostel, in a boys hostel. Suppose you are staying in a hostel, and it is not necessarily be true that all ECE students are staying in the same lobby, right? So if I consider one lobby as a one network, right, and so it is not necessary that every lobby has got only ECE students. So there is a general query that says that which groups have members on attached network. Okay. Which groups have members on attached network, right? So general query, you have to keep a record that how many students are from ECE, how many students are from mechanical, how many are from computer science. So like that, in a particular hostel, how many students are staying, right? So a general query message is served that who is from ECE, who is from mechanical, who is asking. So you can imagine that the clerk is a multicasting router, right? So he inquires from time to time, because router has a routing table that says that how many members are there on this network from a particular group, right? A group is identified by a multicast address, right? Class D address in IPv4. So so each group is identified by an address, and how many members are there on that particular network. So whether they are still there or whether they are not there. So a general query message is sent to keep track of the members, that how many members are still active on this network from a particular group. So it is a general query message is being sent by the router from time to time on a periodic basis to find out which groups have members on this attached networks. Mechanical के भी हैं, ECE के भी हैं, civil के भी हैं, like. But group specific query like how many members are from ECE group, right? So that is a group specific query. Then group and source specific query. Here the source means that like which particular source you want to receive the traffic, which source you do not want to receive the traffic, right? So ideally there should be at least one member present on each network from a particular group, right? So maybe there are more members on a particular group, but at least one member should be present, right? So group and source specific query is related to both the group and the source, like who is sending the traffic. Okay, किससे आपको traffic receive करना है, किससे आपको traffic receive नहीं करना है. So who takes care of these things? This multicasting routers, right? So if I say this membership query, so you can see here that it is the type that says whether it is what kind of query. It is a general query, group specific query, or a group and source specific query. That the maximum response time, that once a query is given, right, how long it should wait. So how much time is given for the response. So that is basically 1/10 second. Maximum time before sending report in units of 1/10 seconds. So before this, it should get back the answer. It should get back a membership report. Okay, checksum, the same thing that you have seen earlier. Group address. So it is 0 for general query message because it is general. Otherwise, it will be if it is a group specific or a group and source specific query, a multicast address is put for this two. So first, let me tell you about the procedure, then I will come back to this. So there is a one membership report also, right? There is a membership query and there is a membership report. So membership query is of three types: general query, group specific query, group and source specific query. While there is a membership report which is being answered, in response to your query messages, right? And this membership report is also used like when a host subscribes to a group or unsubscribes to a group, it submits a membership report to the router. जैसे आप कहीं किसी कंपनी में जाओगे तो first of all you have to submit your joining report that you have joined the X company from this date. Now you are a part of this company, right? So like that, a host, once it subscribes to a group, it has to send a membership report to the router that I am attached to the group now, and what it sends in the address, in the group address, it sends the multicast address of that group. Which group it is joining, the same multicast address it puts in the this address field, right? So it joins a group. Okay, so all the messages being given to coming on that group address will be delivered to all the members. Okay, so host using IGMP wants to make itself known as a group member to other hosts and routers on LAN. So first of all, when any host wants to join a group, so once it joins means it has to make itself known to all other members on the group, right? कोई join करता है नया तो बताता है I have also joined this group, right? So how they say, they send us group membership report with filtering capability. That how can they say that which source they want to receive, which source they do not want to receive? There are two options. There is an include mode, there is an exclude mode. So once this put it in include mode, it specifies the addresses of the member from where it wants to receive the traffic, right? Exclude mode. So if it says exclude mode means it doesn't want to receive from those sources. So it specifies the addresses of the sources like this. group record, multicast address, this source it wants. So every source address is specified that it wants the data or not, right? So to join a group, host send the IGMP membership report message, address field, multicast address of the group, send an IP datagram with group address field of IGMP message with the same group address field at the same group address. The destination address is the same multicast address, so that everybody in the group will get that this particular host has joined. And router to routers also, they hear all the reports, and then to keep track of the, first of all it is about joining, then to keep track of the number of members on a particular network from a particular group, the routers keep checking, periodically issue IGMP general query messages. So that, and there is an important thing that suppose on a particular network 5 members are there from EC group. Okay, so upon hearing a query message, if all of them replies, right, that I am there, I am there, I am there. So in that case, there will be a possibility of a very high load generation. Suppose I just said 5, maybe suppose if all 120 students are available in that group. So if all 120 students replies back to the query messages, there will be 120 interrupts will be generated, right? So how can this situation to be dealt with? So to deal with this situation, what happens? It is maintained that only one, what I said earlier also, that only one member should be present on a network, at least, right? There should be at least one member present on the network. And for that, like suppose if there are 120 students available, 120 group members are there on a, from the EC group on a network, they all should not respond to the query. Once they hear the query, rather only one will, everybody will create some timer. All 120 members will create a timer with random delays. जिसका timer पहले expire हो जाएगा वो send कर देगा report, right? And then the all remaining 119 will not respond to the query. They will leave. Once they hear one query, one report has been given in response to the query, all remaining members will refrain from responding to the query, right? They will disable their timer and they will not respond back, so that the possibility of load generation will be limited. Okay, so a router doesn't need to know every host in a group. So it needs to know only one group member is still active. Okay. So each host in a group sets timer with random delay. Only one member of each group reports to router, right? Then how a host unsubscribes to a group? So it once again, like it joins a group, it sends a membership joining report. Similarly, it sends a membership leaving report. So it sends a leave group message to all routers, static multicast addresses, and it includes, okay, it has to specify that now it doesn't want to receive messages from any of the source, right? It puts an exclude option and null list of source addresses. So exclude means it doesn't want to receive, and with null list of source address means it doesn't want to receive from anyone, right? So this is how an IGMP operation works. So it uses a membership query messages. So this is basically how long it 1/10 of a second is required for reply back. checksum. Group address is a class D IPv4 address or the multicast address of the group. How many sources are there? How many sources from which it wants to receive the traffic, right? So number of sources with each source addresses reserved. This is reserved. S is a suppressed bit, that is suppressed timer bit. So it says that the router should suppress normal timer updates done on hearing a query. So if a query is heard, it should suppress the timer. Then QRV is querier's response value. So it is basically checked, like once a response comes, they set some QRV value, and the same QRV value should be used for the once they send a query, they put some query code, right? And the same QRV value should be used while that query is answered, because there will be number of queries. So how will you check that this is the response of which particular query? So that will be, so this is querier's response value. Okay, robustness variable, sorry. So they adapt value from most recently received query, because this is just like a you can understand, like this is used for like suppose some of the messages may get delayed in the network. So how will you recognize them? That which is the most updated one, which is the most uh, latest one. So how will you do that? So, and it dictates number of retransmissions to assure report not missed. So as the number will be higher, that means uh, that there are how many retransmissions are allowed, right? QQIC, this is a timer for sending multiple queries. So this is a QQIC value, number of sources, source addresses are 32 bits. Similarly, report, so group record 1, group record 2, number of group records. So a facility is there to record a group. IGMP operation, I hope it is clear to you. So as IGMP was available in IPv4 with 32-bit address, but in IPv6 internet needs functionality. So IGMP functions are merged with ICMP v6. There is no separate protocol for IGMP version 6. It is all the IGMP functions were merged in ICMP. So ICMP v6 is basically, it includes all functionalities of ICMP v4 and IGMP. Now coming to the routing protocols, right? Since as we discussed that a multicast for performing the multicasting, a smallest part tree or the shortest part tree is to be created. To create that shortest part tree, we need routing algorithms, right? We need routing and routing algorithms. They will find out the shortest path, right? How can you route the data with the shortest path? So the routing protocols are used. So routing protocols uses two information. One is the routing information that basically deals with the topology and delays in the internet, and second one is routing algorithm, that which algorithm they should use for making routing decisions, right? Before proceeding further, I like to ask you, do you know what is an autonomous system? What is an autonomous system? What is the meaning of autonomy? Anybody?
Sir, dynamic.
Autonomy.
Dynamic in nature.
डायनामिक नहीं, ऑटोनॉमी का नॉर्मल मीनिंग क्या है? What is the meaning of autonomy in general?
अपने से करना, खुद
अपने से करना सब कुछ, right? So if you see here, like BIT, if you take an example of BIT, BIT as an organization is an autonomous institution. So what does that mean? That BIT can take its own decisions. Like if you compare BIT with a state-owned university, right, you will find that BIT is autonomous in framing the syllabus, in conducting exams, publishing of results. So BIT can take their own decisions, right? It is inside BIT. There is one rule, right? As far as the BIT is concerned, we use the similar rule for what is a grade, what is how much marks you are getting, and any example like whether it is a discipline or any kind of thing. The similar rules are followed inside the BIT. So BIT is an autonomous body, right? Similarly, there is an autonomous system, we say, right? That is referred as an autonomous system. So what is an autonomous system? It is basically a collection of routers and networks, right? It is basically set of routers and networks managed by single organization. Are you following? So that is called as an autonomous system, right? So BIT as a whole is one autonomous system, right? And there will be another autonomous system. So once there are two types of routing protocols when we talk about. One is inside an autonomous system, right? As I said, in BIT, we follow the similar rules, right? So in BIT, like in an autonomous system, routing protocols are same. There are two types of routing protocols we discussed. One is called interior routing protocols. Another one is called as an exterior routing protocols. Or you can say intra-domain or inter-domain routing protocols. So routing protocols are based on whether they are applied inside an organization or they are applied between two autonomous systems, right? So all the protocols are not capable of exchanging information all through the networks, right? So you will find a differentiation that some of the protocols can only be used inside an autonomous system. They are most suitable, and some of the protocols are suitable for being used for exchanging information between two autonomous systems, right? So there are interior routing protocols and exterior routing protocols. So this is, they passes information between routers within AS, right? Within AS. Maybe more than one AS in the internet. So routers need some info about networks outside their autonomous system. So basically when we interact between two autonomous systems, there are exterior routing protocols. And when we are dealing with inside an autonomous system, they are called interior routing protocols, or you can say intra-domain routing protocols, right? So you can see that this is one autonomous system, a set of routers and networks managed by the single organization. A similar kind of rule is being followed here, right? जो भी क्राइटेरिया होगा, मिनिमम कॉस्ट का क्राइटेरिया, जो भी मेट्रिक हम लोग यूज करेंगे, दैट metric will be same throughout this autonomous system, right? But because this autonomous system, we may be using, suppose, the number of hops as the metric, okay? But in this autonomous system, there will be some other metric, right? The minimum cost can be a metric. So both of them are different. But when we are talking about between these two autonomous systems, you can see a dotted one is an exterior routing protocols, right? So then there should be a uniformity when we are discussing with the other autonomous system, right? जैसे आप suppose a Chennai guy will talk only in Tamil when they are in Tamil Nadu, but when they come to Jharkhand, they speak either in English or so you can say that the English is a exterior routing protocol, and inside this the Tamil is a local language that we are using, right? Inside Tamil Nadu. So that is the difference in our interior routing protocols and exterior routing protocols, right? So now we will discuss some algorithms, right? First, that is a distance vector routing. आपने पढ़ा भी था पहले पिछले सेमेस्टर में about distance vector routing and लिंक स्टेट तो नहीं पढ़ा होगा. Dijkstra algorithm पढ़ा था ना, डिस्टेंस वेक्टर रूटिंग का ही एग्जांपल था. ओके, so here how does it work, distance vector routing? So you can imagine a scenario here. So this is, you can see there are 5 nodes, okay, A, B, C, D, E. So in this, what is DVR, distance vector routing? That here each node is having a distance vector, okay, stores its distance vector in this kind of table, right? So here, suppose A is directly connected with B, directly connected with C, directly connected with D. A has no idea about E, right? So once, so it has, A has its distance vector. So distance vector routing is like, let's say कोई एक map है किसी जगह का, right? Everybody is having और वो जैसे पिक्चरों में नहीं होता था कि some that map is torn off and some portion is with some persons and some portion of the map lies with the other section of persons. So once they join it, they get the complete map. Similarly, here also distance vector routing, like you can consider it, there is a map, okay, everybody will have some portion of the map, and once they join it, they knows, जैसे जैसे आप portions को जोड़ते जाओगे, like map, the different pieces of the maps, you will be able to find out where you can reach, right? So initially A has this knowledge that it can reach D, it can reach C, it can reach B, right? But with the time, it will come to know that once C or B share their maps or distance vectors with A, right? A comes to know that, oh, E also can be reached. Okay, first suppose B shares its table with A. Then A knows that, oh, I can reach E via B. So the cost is 5 plus 7, 12. And the moment C shares its table with A finds out the least cost path. Okay, that I can move via C. It will be 3 plus 2, 5 only, right? So this is how the distance vector routing works, and the protocol based on distance routing on distance vector routing works, right? So you can imagine, and the difference is here that each node shares its distance vector with its neighboring nodes only. Those with their neighboring nodes. Okay, E will not share with A. E can share only with C and B, right? C will not share with D. It will share with A, B, and E, right? So the nodes share their distance vector with their neighboring nodes, right? And based on that, and once they receive the information from their neighbors, right, they update their tables based on that. As I said, the moment C shares its table with A comes to know that I can go to E via C, right? So that is the difference. So here the nearest neighbors share their tables, right? This is called a distance vector routing, and like that they keep on doing it. They keep on doing it. So updates. This is called as a periodic updating of the tables. So whenever there is a change in the network somewhere, they update their routing table. As I said that initially A was aware about B, and then once B shares its table, it comes to know about E. But the moment A shares its table, C shares its table with A comes to know that it can reach E via C, right? And so A updates its table based on that, and it shares its updated table with all its neighboring nodes, including D, C, and B, right? So this is how the distance vector routing works, and there are a lot of things in distance vector routing. This is the limitation of time. I will not discuss much about that because there are many things like the infinity, split horizon, closed loop problem. Since limitation of time and I don't find that much interest also, so I will skip it. It is given in Forozen. You can see it. If any doubt is there, I can explain it anytime, right? So this is about a distance vector routing, and there is another algorithm on which our routing protocol is based, that is called as a link state routing. So how the link state is different? In this case, like here I told you that they share with only the neighboring nodes, and there it is like a map of a city, which is everybody will have a piece of that, and they once they share this they understand. So and the protocol based on this is routing information protocol, RIP. So it uses basically hop count as a metric, and the maximum value of this is 15. Okay. And the other one is, and it was used in ARPANET, which we have used earlier. And in link state, it is just like that every node has got a link information. It has got a map, its own map. पहले क्या था कि मैप जो फटा हुआ था, सबके पास कुछ कुछ पीसेस थे, and when they join it, they understand that how can they reach. But in this case, every node has got a link, like every node has got a map that how can it reach to the other nodes. Okay, link state. So it has the all link information to reach from A to B, A to C, A to D, right? That what is all kind of link information is available on this in this. So A will have a table in that all the link information to reach A to D, A to C, A to B will be maintained. So everybody has got a map here. Everybody has got a full map. Okay. And once they share their map with the others, okay, they understand, and once the other nodes share their map with the other nodes, then after sharing is over, they generate a final link combination. So that is basically the shortest path, right? So link state means they share all possible information about the link, like that what is the link cost, right? What is the topology? Everything they share, right? So, so this information is being shared in the form of link state packets. Link state packets are constructed. They consist of all the link related information, a sequence number on it, and rather than sharing with the neighboring nodes as compared to the distance vector routing, here it floods the node, floods its information in the network. So like the link state information is flooded in the network so that every node will receive it. Okay, so it generates a huge load in the network. Link state routing generates a huge load because these link state packets are flooded in the network in all routes, right? So that it can reach to all the members in the network, and based on this information, every member in the network, every host in the network updates its routing table, right? Now, when they should share their tables, the first thing is that they can share their routing tables only on some periodic basis, right? They say after 1 hour they will share. But as you know that in an internet environment, the things are changing very fast, right? Some of the nodes may not be a part of, may get down, right? So some of the links are not working. So these things may happen. So you can see that it is a dynamic environment, right? So in a dynamic environment, the changes happen very quickly. So once any change in the topology or any change is reported by a particular node, so what it will do, it will update its table and will flood the information in the network. So there are disadvantages also, that by the moment the information reaches from this node to this node, right? By the time another change has taken place, so the information doesn't get updated very fast, right? And it creates a lot of load in the network. So this is the link state routing. So a protocol based on this is called OSPF. It is still used, open shortest path first. Is also used. So it is basically designed to overcome drawback of distance vector, because in a distance vector there was a issue that the metric it uses a hop count, right? And it is fixed to 15 just because of a node instability problem. What is that node instability problem? Suppose once the C shares its table with A, right? Because some packets may not be delivered, right? So what will happen? There may be a confusion between the nodes that from where they should move, right? And because of that, there is a problem that this will keep on, the metric will keep on increasing, right? So that is called as a 2-node instability problem, 3-node instability problem. So because of that, the highest one is fixed to, so the maximum number of hops are fixed to 15. A value of infinity is defined as 15 for a distance vector, right? So each router construct topology and entire configuration. They can calculate shortest path to each destination network. Router constructs routing table listing first hop to each destination, right? So it is basically like a Dijkstra algorithm, which you have done in the previous semester to find out the shortest path. Two algorithms you did. One is Dijkstra algorithm and another was the Bellman-Ford, right? So this is the protocol. Now these two algorithms, because of their limitations, first of all, they are not suitable for exterior routing protocol. Why? Because they share common distance metric. Because distance vector assumes routers share common distance metric, like it uses a hop count. That may not be true in different autonomous system. There may be another metric, and moreover, a limitation of 15 hops. Okay, that is a maximum count in a distance vector routing. So that puts a limitation for DVR to be accepted as an exterior routing protocol, right? On the other end, in a link state routing, the main drawback was the huge load generation, right? And both of these algorithms, link state and distance vector routing, there was no policy routing available. Like suppose if you want to avoid a portion of the network which is unsafe for your data, right? So there was no provision in both the cases that was not available. Policy routing was unavailable in both distance vector and link state routing. So here we have so these limitations disqualifies them to be used as the exterior routing protocols. Okay, so which are the autonomous system you are visiting on the route? This information is not available, right? So a third algorithm that is based on and different AS may use different metrics, as I said. So there is a path vector routing. A path vector routing is like there is no metric associated in this, right? Like in link state routing, there was a minimum cost. In a distance vector routing, there was a minimum number of hops. But here in path vector routing, no metric is associated because different AS may have different metrics, right? So it provides only information about which network can be reached by a given router and autonomous systems cross to get there. So it doesn't include distance or cost estimates. Rather, it includes only the path, that how will you move. So it allows a policy routing that this particular portion of the network should be traversed in order to reach from a source to a destination, right? So it enables router to perform policy routing. It avoid path to avoid transition particular autonomous system. So these are some of the metrics which are used here, like minimizing number of transist autonomous system. That how can, so this can be the metric which is used in path vector, that how can you minimize the minimum number of transits, link speed, capacity, tendency to become congested, overall quality of operation, security. So all those can be the metrics used in path vector, and the protocol based on this is called as the BGP, Border Gateway Protocol. So Border Gateway Protocol is an exterior routing protocol. So this we will do in the next class, as the time is about to over. Next Wednesday we will have a quiz. Okay. The coming Wednesday we will have a quiz. Okay.
Yes.
Okay, sir. Thank you, sir.